Okay, you guys should have your notes packets out. We are going to be taking notes on 11.4 inscribed angles. So we'll start with defining what an inscribed angle is. An inscribed angle is an angle whose vertex is on the edge of the circle. So if we look at our circle to the right, we're going to go ahead and draw an inscribed angle. So if we want the angle, if we want the vertex to be on the circle, let's say this is the vertex. This right here is going to be the inscribed angle. Again, you see that the vertex of the angle is on the actual circle itself. The intercepted arc is the arc that is formed where the two rays of the angle intersect the circle. So here, this is going to be the intercepted arc. Alright, so this is the vertex of your angle. This is the inscribed angle because the vertex is on the circle. The part of the circle that the rays intersect create, that's going to be the intercepted arc. Two vocab words that you're going to need to know for today's lesson. So let's talk about the inscribed angle theorem. The measure of an inscribed angle is half of the measure of the intercepted arc. So again, this is our angle. This is the intercepted arc. So what it's saying is the measure of the inscribed angle, let that be x, is half of the measure of the intercepted arc. So if this is x and that's half of it, this is going to be 2x. You could also think about it as if this was x, then this is going to be half of x. Some people prefer not to deal with the fractions. So just whatever you know is the angle on the inside is going to be half of whatever the outside is. So you can go from the outside and cut it in half, or you can go from the inside and double it. Let's do a couple examples with this. Find the measure of each of the angles. So we're starting with the angle. We know that the intercepted or the inscribed angle is going to be half of the arc. So we can go do this a whole long way. The inscribed angle is half of our arc BW, and we want to solve for BW. To get rid of 1/2, we can multiply both sides by 2, and we end up with our arc BW is equal to 124 degrees. Now most of you are probably sitting there thinking that was way too difficult. We know that if this is the inside, we just multiply that by 2 to get to the outside of 124. That's all you have to do. You don't have to make it more complicated than it is. So if we have the arc this time, 98 degrees, if I'm going inside, I'm cutting that in half. So all I have to do is take 98 degrees divided by 2, and we get 49 degrees. So our angle on the inside is 49. Angle NBC is equal to 49 degrees. Alright, when we look at number 3, we've got a little bit more complicated diagram here. We have two things to find. We want to find arc FB, and we want to find arc ALB. So let's go ahead and look at the arcs that we're looking for. Arc FB would be this arc right here. We know that we wouldn't be going the other direction because I'm going to go from F directly to B. I'm not going to cross any other letters. If I were to, the way I do in the second one, I would give you the middle letter. So I want to go from A to L to B. So these are the two arcs that I want to find. If I'm going to deal with those arcs, I have to find their inscribed angles. So if I look at ALB, I see that here's one ray, but there is not a second ray. So that's not an intercepted arc. So I can't do my rule there. I look at FB. Again, there's one intercepted ray. There's one ray crossing there, but there's not two. So I don't have intercepted arcs for the arcs that I'm looking at. So I'm going to go ahead and see what I do have. I see that I have a 130-degree angle right here. That is my inscribed angle. The intercepted arc is this whole thing. So I know that if this is 130, the angle is half of the arc, so I double that to get that the arc is 260 degrees. I also have this inscribed angle. And this inscribed angle has this intercepted arc. If this is 83, I double that to get 166. So I can go ahead and use this information. Let's go ahead and find FB first. If I look, the purple goes from B to F to A. This whole thing is 260. Well, I know that this part is 166, so to find the arc FB, I can just take that 260, subtract the 166, and I find that the arc FB is equal to 94 degrees. Again, the purple was from B to F to A. I subtracted the 166 and I was left with just the FB. Now I still have to find our arc ALB. I know that the whole thing from B to F to A, once again, is 260. Well, this is the other part of the circle. That cuts my circle into two pieces. And to find the measure of arc ALB, I know that the entire circle has 360 degrees. So if I subtract out this 260 that we found for BFA, I find that I'm left with the measure of my arc ALB to be 100 degrees. So sometimes it might not directly be given to you, but you're given enough information that you can take multiple steps to get there. Alright, that's our first one. Our second theorem here, corollary, is if two inscribed angles intercept the same arc, then the two angles are congruent. So I have two different angles with the same intercepted arc. So let's go back up to our first diagram. Remember what the intercepted arc is. It's the part of the circle that was created by those two rays from the angle. So I'm going to look at angle B. Here's my angle B. Angle B is created by these two rays giving me this intercepted arc. Then I'm going to look at angle C. Angle C is created by these two rays, and those two rays have the exact same intercepted arc. I could use my first theorem, the inscribed angle theorem, to say, well, if this was 100, then this is going to be 50 and this is going to be 50. Again, I just made up those numbers. That's not necessarily true. So what this corollary says is if they have the same intercepted arc, then those angles, the inscribed angles, are going to be congruent. So again, as we just said, B is going to intercept that arc AD, and angle C is going to intercept arc AD. Therefore, angle B is going to be congruent to angle C. Alright, go ahead and flip on over to the back side. Next page. We have another corollary. If an inscribed angle intercepts a semicircle, then the inscribed angle is well, let's first think about this before we fill this in. A semicircle is how much of a circle? Yes, it's half of a circle. A whole circle is how many degrees? Yes, 360. So I know that a semicircle is 1/2. So if my arc is 1/2 of a circle, leaving me with 180, and the inscribed angle is half of that, that leaves me with 90 degrees, which is a right angle. So why does this have to be true? Again, we just said, here's my two rays. The inscribed angle intercepts a semicircle. So here's my arc. My arc is exactly half. I know it's exactly half because I have a diameter that's going through the center of my circle. We know that half of a circle is 180. If I cut that in half, because it's an inscribed angle, because the vertex is on the circle, it's going to be 90. So let's go ahead and use our theorem and our two corollaries to go ahead and solve some problems. Number 4, we want to find x. So we want to solve for what our x is. We look, the first thing that should jump out at you is we have a diameter. There's the center of my circle. There's my diameter, which means that this right here is a semicircle. That means that this is representing 180 degrees. If that's 180 degrees, that means that this is 90 degrees, a right angle. So we have an expression, x squared minus 54, representing a 90 degree angle. Since those two things are representing the same thing, I can go ahead and set them equal to each other. We move our 54 over. We get x squared is equal to 144. We take the square root, and we find that x is equal to plus or minus 12. And when I look in here, sometimes, remember, our x's can be positive, sometimes our x's can be negative. What matters to see if it's true or not is the angle positive, is the angle negative? We know we can't have negative angles. So if I plug the negative 12 in there, a negative 12 squared is going to give me a positive 144 minus 54, which, yes, I'm going to get our positive answer of 90 degrees. So we actually have two possible solutions here. X is equal to a positive or negative 12. Number 5, we want to find arc ZL and we want to find angle D. So as our diagrams become more and more complicated, you kind of want to dissect things. So first, I want to find arc ZL. So I'm going to look at my diagram and see where that is. And I want to find the measure of angle D. So I want to find that angle and that arc. I'm not given any expressions for the arc. I'm given an expression for my angle D. So I have to look at that diagram and I have to think about the theorem, the inscribed angle theorem, that the inscribed angle is half of the arc. That's not going to help me because I have an expression for the angle, but I don't have an expression for the arc, and I can't find the arc. So then I go to my next corollary, and the next corollary was if two inscribed angles have the same intercepted arc, then they are congruent. So I'm going to say, okay, I have my intercepted arc of ZL. Are there any other angles that have that intercepted arc? Yep. I see that angle E has that same intercepted arc. What that means is that angle D and angle E are congruent. I have an expression for angle D, I have an expression for angle E. So I'm going to go ahead and set those two things equal because the angles have the same measure. We have x's on both sides. I move the smaller x to the right. That way I keep a positive 5x. We move the 15 from the right to the left. I add that. I get 45. We divide by 5, and we get x is going to be equal to 9. Now remember, this is a good multiple choice question. The question was to solve for ZL and the measure of angle D, not to solve for x. So we can't just stop there. We have to go ahead and find our missing pieces. So we want to find the measure of arc ZL. I don't have an expression to plug x into for ZL, so I'm going to move on to angle D. Angle D is being represented by 3x plus 30, so I plug my x in of 9. We've got 27 plus 30, and we find that the measure of angle D is going to be 57 degrees. Now if this is 57, I can finally solve for our arc ZL. We know that arc ZL is going to be twice that angle measure. It's always going to be double the inscribed angle. So we have that arc ZL has a measure of 114 degrees. Okay, let's go ahead and move on to example number 6. We want to find the measure of angle S and the measure of angle GOB. So angle S, again, let's go ahead and find out what we're looking for. There's angle S right here, and here is angle JOB. We look at what we're given. We're not given any expressions. We're not given the intercepted arc, but I am given that from arc J to S is 150. I'm given arc SB is 100. Don't forget that all three angles in this case, or all the arcs that create the circle, have to add up to 360. So we can find arc JB by doing 360 minus 150 minus 100. And we are left with arc JB equaling 110 degrees. And that will help us find first our angle S. Well, angle S is the inscribed angle from that arc. So that's going to be half of that arc. So our angle S is going to be 110 degrees. Remember, inscribed angle is when the vertex is on the circle. If you're going from the arc to the angle, you cut it in half. If you're going from the angle to the arc, you double it. And we have one more piece left, our angle JOB. Now that has the vertex in the center, and this is something that we've already learned, that the arc, and if the vertex is coming from that center, these are the same. So angle JOB is 110 degrees. Okay, what I want you to do is press pause on the video and go ahead and try number 7 either on your own or with your group members. So see if you can go ahead and find what the measure of arc ABC is. Go ahead and press pause. Take 1 or 2 minutes and then press play when you are done. Okay, so let's see the information that we have here. We want to find, our goal is to find the measure of arc ABC. So again, I'm going to go from A to B to C. So from A to B to C. So this is the arc that my goal is. I use all the information that I'm given. If this is 30, then arc AD is going to be 65 or 60 degrees. If this angle right here is 65, that means that this arc is going to be 130. The next thing that you had to realize is that you had the center of the circle there at O, which means this is a semicircle, which means that this half is 180 and this half is 180. So from B to C to D, if this is 180 and this is 130, we have 50 degrees left. From here, from D to A to B, this is also 180. So if this is 60, then this has to be 120. So when I'm looking to go from A to B to C to find the measure of that arc, I have to add together that 120 and the 130 to find the measure of that arc. ABC was 250 degrees. Okay, we are almost done. Our last theorem, our inscribed quad theorem. If a quadrilateral is inscribed in a circle, so inscribed, all of the vertices are going to be on the circle, then its opposite angles are supplementary. So that means opposite B and D are opposite angles. So angle B plus angle D, if they are supplementary, they are going to add up to 180. A and C are opposite, so angle A and angle C, those two angles are going to add up to 180. This could be confusing from what we learned about parallelograms. In Chapter 6, parallelograms, they're adjacent angles were supplementary. So this is completely different. Make sure that you have these two rules separated. If it's a parallelogram, then the angles right next to each other are supplementary and opposite angles are congruent. But when your quadrilateral is inscribed inside of a circle, again, all vertices are touching the circle, then opposite angles are supplementary. So if I want to use this theorem to solve, angle M and angle C, those are my opposite angles. So those are my angles that are going to be supplementary. So I take that 6x plus 20 from angle M, and I add that to 3x plus 25 from angle C, and I set that equal to 180. Those two angles being supplementary add up to 180. Combine my like terms to get 9x, 20 and 25 to get 45. Move our 45 over to the right-hand side. We get 9x is equal to 135. We divide by 9, and we find that x is going to be equal to 15. Now my goal was not to find x, my goal was to find the angle measure. So I'm going to find all of those angle measures. And that means we have to plug things in. So to find the measure of angle M, we have 6 times 15 plus 20. And that's going to leave us with angle M as 110 degrees. Now you could go to angle C and say 3 times 9 plus 25 and get that is 70 degrees. Or you could have said, okay, well that's 110 and they're supplementary, then this has to be 70. So you don't have to necessarily plug that in. We do have to plug in for angle K. 10 times 9 minus 69 is going to leave us with 81 degrees. If that is 81, the opposite angle is supplementary. So to find angle N, we do 180 minus 81 degrees to find that that is going to be 99 degrees. All right, go ahead and turn on over to that next page. We are going to take all of the rules that we learned today to complete number 9. We want to find all of the arc measures and all of the angle measures indicated over here on the left. You've got to go step by step, use those inscribed angle theorems, think about your semicircle, think about the relationship between arcs and the inscribed angles. The whole circle is 360. You're going to go ahead and press pause again. And then when everybody is done, a minute or two, you can work alone or in your groups. Go ahead and press play and see how well your group did. Okay, so before we even look at the left-hand side, I'm going to fill everything in that I know. This is a central angle. That is 100 degrees. That means that arc BC is also 100 degrees. Inscribed angles are half, but this is a central angle. I look at 150. 150 has rays cutting at C and at E. The angle is half of the arc, so I'm going to double 150. That's going to give me that entire arc, EBC, of 300 degrees. And I know that if this whole thing is 300 and the whole circle is 360, from here to here has to be 60 degrees. I gave you that E to D is 20, which means that from D to C has to be 40 degrees. There's one more thing I see right away, and then we'll go ahead and go to our pieces to see if we missed anything. So we know that from E to B to C is 300, and from B to C is 100, which means that this arc over here is going to be 200. So let's see if we filled everything out that we needed. We want arc BC. First thing we did, 100 degrees. We want arc CBE. So from C to B to E. That's our pink. That's 300 degrees. Now we want angle ECD. So we want angle from E to C to D. So we concentrated on arc, so we've got a little bit more information we got to fill out. The intercepted arc here is 20. That angle is going to be half, so that's going to be 10 degrees. Alright, next we want arc CD, so let's get our diagram from C to D. We already had it, that was going to be 40 degrees. We want angle BEC, so from B to E to C. This is the intercepted arc. That is going to be twice as much as the angle, so we cut that 100 in half to get a 50-degree angle. We want arc BE, so from B to E. We already have that filled out. That's our 200. And last, our angle CED. So we are looking from C to E to D. That has the intercepted arc of 40. We take half of that, and our last piece of information is 20 degrees. Okay, we are done with our notes. As you see, the rest of your page there is going to be group work. You're going to work on this for the remaining of the time. You have 5 questions to work on. The answers will be up at the front, so as you're working, go ahead and check your answers to make sure that you are correct, and you have homework in your book tonight. Alright, you probably should have about 10 minutes or so to work on this group work, 10 to 15 minutes. So go ahead and good luck.